Okay, let's talk about the most important measure of deviation, which is standard deviation. This is the most important measure of dispersion. This was introduced in 1893. In 1893 by Carl Pearson. Um, okay. Essentially, it caters to as the best measure of dispersion because it is free from all the defects that any other measure of dispersion has. Like, the range is not satisfactory as its value is affected by the most extreme items. And in quartile deviation, as we know, it is not based on all observations either. Mean deviation, it ignores the algebraic signs of deviation, which mathematically is really false. So, standard deviation is one method which is free from all these defects. That's why it's supposed to be one of the best measure of dispersion. A small standard deviation would actually mean standard deviation would actually mean high degree of high degree of uniformity of observations as well as homogeneity. Observations and homogeneity of the series. And of course, as large standard deviation would mean the opposite of it. Now, standard deviation is superior to mean deviation on which ground? On the ground that it considered the algebraic signs of deviations, and deviations are taken from the mean, the most satisfactory measure of average. So, what is coefficient of standard deviation or coefficient of variation? It is of standard deviation is essentially sigma upon the mean, sigma upon mean into 100. Now let's see how you can compute standard deviation in terms of individual series. So let's say there are n individual observations x, n individual observations with mean value x bar. Then the direct method to find out standard deviation is sigma equals to essentially square root of summation of x minus x bar square whole square upon n, and this gives us our standard deviation. So what are the steps involved? First of all, compute x minus x bar, then square it, and then sum the observations, and then you find out, then you find out the mean of that, and then you get your by taking a square root you get your standard deviation. For example, if you have a data series like this, 11, 12, 13, 14, 15, 16, 17, 18 and 19, 20, 21. Okay, now what is x bar? X bar, if you see, it will come out to be 176 upon 11, which is 16. 16 is x bar, and if you find out Your x is that, this x minus x bar, first of all you need to find out, then x minus x bar whole square. So 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Now x minus x bar is minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. And you square it, you get 25, 16, 9, 4, 1, 0, 1, 4, 9, 16, 25. So the sum out here, so sigma will be what? Sigma will be the sum of this is 110 upon 11, which is root 10. That is 3.16 is the standard deviation.